Hey, this is Vedat from Programmership. In this chapter, we're gonna talk about copy on write feature in Swift. And we will also make an example that will show how to implement the copy on write feature to a custom object. But first, it is better to remember the difference between reference type and value type. When we create an instance of value type and pass this instance to an object, a new copy will be created. That means both value type instances will look at different memory address. If we make any change in one instance, the other one will not be affected by this change. So what about reference type? When we create an instance of reference type and pass this instance to an object, the new object also will look at the same memory address. That also means if we make any change in one of the objects, the other one will be affected by this change. This is basically how reference type works. Also, as we know, classes are reference type while structures are value type. Let me show you a basic example to see the difference. Let's create a basic structure. Here, let's say struct. I'm gonna call it person, and inside the person structure, I will just create a parameter called name. It will have a string value, which is Vedat. Now I will create an instance of our person structure. Let's say var first person is equal to person. Also, let's create another variable and pass the first person instance to that variable. Let's say var second person is equal to first person. By the way, it must be first, not first. Sorry for typo. Alright, what happens when I make a change in first person instance? Say first person dot name is equal to, I will say Adam. And let me print the both persons name property. Let's say first person is first person dot name, and for the second person I will say second person dot name. Let's hit run. And we can see the first person's property was changed, which makes sense. But the second person's property is still Vedat. So this is because both variables look at different memory address. We can also see the memory address of these variables. Let me create a function that returns the stack memory address of the given instance. For that, here I'm gonna create a function. Let's say get address, and for the parameter I can say target, and to get the address it will be unsafe row pointer. And for the return type I will say ns string. Inside the get address, let's create a constant which is address, and we will get the address from the target parameter by testing it to integer. It will give us address in integer format. To do that, I will just say int with the bit pattern, and for the parameter I will pass the target. And now inside the address constant, we'll have the target memory address in integer format. For the return, I will format the integer array and make it hexadecimal. Let's say ns string. For the format, I can say percentage and p. For the argument, I can just say address. So with p percentage, we will return the address in hexadecimal format. And let's call this function to see our instance address. Here I will say print first person address is get address. For the target, I will use ampersand and first person. Let me copy this and paste it again. This guy will be second person, and also this will be second person. Let's hit run. And we can see the both address are different. This is how value type works. Well, let's see how the reference type works. But first, I will delete all of this structure example, except the get address function. Let's leave it here. Now, we will just create a basic class. Let's call it student. This is my student class. I will also create a property inside the student class, just as I did in structure, and that will also be Vedat. and I will create two variables and do the same thing as I did in structure. Let's say var first student is equal to student. Also, let's create the second student object, and this will be equal to first student. Here I will try to change the first student name property into Adam, or let's say George for this time. And then I will try to print the first student name property and also the second student name property. Let's say first student.name. And let me copy this print statement and paste it again. This will be second student, just like that. Let me hit run. And we can see, even though I only changed the first student name property, both student objects were changed because both objects are looking at the same memory address. We also want to see these objects' memory address. We have to use something else rather than using getAddress function, because the getAddress function is used for stack memory address while classes are stored in heap memory. I will also create a function that will return the heap memory address of the given instance, and our function will be generic. Let's say func get heap address T for the parameter generic type, and the type will be any object. So for the function parameter, I can say target, that will be T again. For the return type, let's say NSString again. Inside the getHeapAddress function, let's create a constant again that will be equal to unsafe row pointer, and for the first parameter I will just pass target. For the second one it will be to end.self. We'll get the address from the generic parameter by using unsafe bitcast function. It will give us address in bits. So let's also format this bit into hexadecimal. For the format, I will say %p. For the argument, let's say address. This will also returns the address in hexadecimal format. By the way, it is not unsafe row pointer, it must be unsafe bitcast. So sorry for that. And I'm gonna print the first student and second student address. Let's say print first student is also, let's say address is first student, but we need to call the getHeapAddress function for the target. Let's pass the first student instance. And let me copy the print statement and paste it again. For the second student, we'll just pass the second student instance. Let's hit run. And we can see the both objects are looking at the same memory address. Awesome. Well, after remembering the value type and reference type, it is time to talk about copy on write. As we saw in the value type example, when we create an instance of a value type and pass this instance to another object, a new copy will be created and both instances will look at different memory address. Think about an array that contains thousands of value type instances. When we pass this array to another object, or into a function as a parameter, a new copy will be created. That means a new copy of thousands of instances will be kept in the memory. You can see this situation can affect the performance of our app. In this case, the copy on write feature comes into play. The logic is simple but very useful. Copy on write feature basically states when we pass an instance of value type to another object, a new copy will not be created until any modification is needed. If any change is required, then before the change, a new copy will be created. It is very effective when we need a value type instance just for reading. With that copy on write feature, a new copy will not be created until we make a change. So remember, arrays and dictionaries in Swift are value types. This copy on write feature has already been included in arrays and dictionaries. So we don't have to write extra code for that when dealing with arrays or dictionaries. Let me copy the structure example that we did and see how this works. So let me delete all of this and paste it here. Now I will change the first person data type from person structure to person array. Let's say it is an array of person type, and we will just create an instance of person inside the first person array. And now let's print the address of both person objects. let's say print first person address is get address ampersand, sorry, first person. And let's do the same thing for the second person as well. Let's say second person. Hit run. And we can see both objects are looking at the same memory address because the copy on write feature was in play right now. Let's see what happens after making a change in the first person object. Here, let's say first person's, the first item name property is equal to, let's say, Isaac. And also let me print a separator to see the difference better. I will just copy these two lines and paste it here again. And let me hit run. And after the change, we can see the memory addresses are different right now because we did a modification and a new copy was created. I think you got the idea about copy on write feature. Well, let's take a look at how we can implement this copy on write feature for a custom object. Hopefully in Swift GitHub account, there is a basic code wrapper for implementing copy on write feature. I will also put the link down in the description so you can have it. Now I will use the same wrapper here, but write the code down step by step instead of copy and paste. Here at the most top, let's begin with creating a generic class. I will say class, the name will be reference, ref, and it will be generic. To avoid inheritance for this class, let's also add final keyword. Let's say final. Now we will add a property which type is generic and also create an initializer for ref class. Let's say var, the parameter name is val, stands for value, and its type will be t, which is generic. And for the initializer, I can say init. It will have a parameter, let's say v, it is also in t type. Inside initializer, I will just say val is equal to v. That's it for this class. Now I'm gonna create a structure that will do the main work. This structure also will be generic. Here in the next line, let's say struct box. This will also be generic. Well, now let's add a property in our generic structure, which type is ref class. Let's say var ref, and its type is ref t, just like that. Also, let's add an initializer. Let's say init. For the parameter, we can say t, and inside the initializer, our ref property will be equal to new instance of ref class. Let's say x, just like that. Now, the most important part is coming, guys. I will add a computed property which type also is generic into our box structure. Let's say var value, it is generic type, and for the get property, it will return the reference value. Let's say ref.val. Let's also add set property. Remember, in the copy on write feature, each instance should look at the same memory address until a change is made in one of the instances. So to do that, we will use the set property, because if the set property is triggered, that means a change is coming. We also need to know whether or not our memory address is used by more than one instance. There is a function called is known uniquely referenced. This function returns true if the given parameter's memory address is used by only one instance, not more. If the address is used by multiple instances, then it returns false. Well, inside the set property, let's check if our address is used by multiple instances. If it is, then we will create a new copy. Let's say if the ref property is not unique, then create a new copy. Say ref new value, and also return. If our memory address is used only by one instance, then we can just perform the changes without creating a new copy. Here I will just say ref.val is equal to new value. Now in the person structure example, let's change the first person type from array to box structure. I will just say box. And here let me delete these lines. In the first print statement, I will try to write first person address. But instead of this notation, I will say first person dot ref dot value. And for the second person, I will just say ref dot value. Just like that. Let's hit run. And we can see each instance is looking at the same memory address. The copy on write feature was in play. Good. What happens if I made a change in the first person's name? Let's say first person dot value dot name is equal to, I will say Adam. In the next line, let's print some separator. I will just copy these two print statements and paste it over here. And let me hit run again. Now, after the change, they are looking at the different memory address. All right, that's it for this chapter. I hope every piece of the chapter was clear enough to understand. See you in the next one. Goodbye.